And good morning, all you beautiful people. Thank you for coming along this morning. Yes. Okay. Imi has the right sort of attitude for today. So before, okay, something that is even more important than ever. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, that could open a whole conversation in itself, but I'm not going to get into it. Not right now anyway, because we've got boards to build. Good morning to Austin, Michael, Stephen, Amanda, Tassie Bob is here, Russell, Sion, thanks for coming along to check out how boards are assembled by people with basic gear. Gerald, is here Stephen? I think I said hello to Stephen earlier. Andrew Brown is here. Chip, David, Crisp is here. Michael, Trady. I think I said hello to Trady. Anyway, I'm losing track. Who am I talking about? Already, hang on. I'm getting a warning out of YouTube's console already that the bitrate is lower than it should be. Great. That's a good way to start the stream, isn't it? Good morning, Keith, Henrik, Johan, Simon, Dentistries, you made it, Incognito. You're looking so happy today. I'm trying. It is grainy, yes. The NBN is failing us again. Yeah, decidedly 480p like. That's right. Yeah, I am pixelated. This is 8-bit John. Studio is here. Studio Rays. All right, now. So, what we're going to do today, fellow cyborgs, is... oh, what our schematics look like. Okay, well, hopefully it gets better. All right, so... this is going to be quite tricky to be doing all of this on my own because I've got different camera views and things that I can, hang on, I'm just going to think about if I change this. It is really confusing because I've got multiple cameras coming into OBS. OBS then goes into the ATEM, which has multiple cameras as well. So I've got lots and lots of video sources and it is totally confusing, and I'm going to be trying to drive some of it from the other room while I'm in next to the machine. So if I switch to that view, I'm just doing this for my own benefit. Alright, so this, for example, is the view right now from inside the clean room. There is the first KO that you can see at the start. That one is the one that we're about to use to assemble the board. And if I switch to, how am I going to do this? This one, camera 7. So this is this is a security camera, like an IP camera, which is physically inside the pick and place machine. And if we move it around, in fact, I can do that from here. I'm going to, now what I will do first is, I also have this view. So this is a remote screen capture. So if I go back to this view, Alright, if we're looking at this view, you can see up towards the top left there is a black looking monitor. The monitor is actually turned off right now, but the computer that it's plugged into is doing screen sharing, and if we come to this view, this is looking at what would be displayed on that monitor if it was turned on. So we can drive the pick and place machine by remote control using this screen share. So I'm just going to turn it on, and you can see I've already got a pick and place job loaded, and I've got all of the parts to find here. Now, in just a second, I'm going to hit this home button. But before I hit the home button, I'm going to switch back to camera 7. Alright, I'm going to hit home now. And what is happening is that, you can't really see it, but that conveyor belt is running right now. It is running just to clear itself and make sure there is nothing sitting on it. It uses the exit detector. Oh, you would have just seen it jiggle a little bit. That was as it was homing. And now it has just homed the main head. So if I really wish I was doing like picture-in-picture on this so you could see the user interface at the same time. But from here I can drive the machine. So I'm just jogging it around. I'll bring it over towards the front a little bit so the head is sort of in the vague region of the discard tray at the moment. And if I hit park, woo, it'll send it off towards the back right corner, sitting out of the way. And you can see just on sort of towards the bottom left of the screen there's a blue PCB. It's sitting on a holder, like little posts that hold it up off the base plate of the machine. Normally PCBs would be going through on that conveyor belt at the front, but this particular board is just a single loose board. It's not in a panel, it doesn't have edge rails, and it has parts close to the edges, which means that I can't put it on the conveyor. So I have to just sit it on those little standoffs in the back of the machine, which is part of a clear area where you can put in things like trays, and so if you've got trays of parts, you can mount them back there. That's actually what those little standoffs are meant to be for. It's for holding a tray in the back of the machine. Okay, so we will get back to all of that. Alright, what are we doing now? What are we going to do? Okay, you know what we need. We kind of need solder paste, don't we? But am I even still online? I don't know. I've got warnings going on the YouTube console. Yes, I am here. Good. Now, is the microscope working? It looks like the microscope might have actually stabilized. I turned it on earlier because it was, the camera in it flickers a lot. But what I'm going to do is, I have here some PCBs. So there is one board, at the moment there is one of the bare boards sitting in the back of the machine, and I did that just for setting up the pick and place job to get the position right and everything. But I'm going to pull that one out and replace it with one with solder paste on it. So what I'm going to do next is paste up this board, and what is that part? I don't even remember. What is that? Oh, that's right. That's the USB controller chip. So a lot of this is going to be me faffing around looking for parts today. But hopefully this will work all right. Let's get some focus on this microscope. And the first part of it is going to be just me sticking on some solder paste, doing it the manual way. Where did I put that solder paste? I thought I got it out of the fridge earlier, and it should have, oh, there it is. I was just going to say it should have been sitting on my bench, and of course it is sitting on my bench. Where's the lint-free wipe? There we go. Okay. Now, what is going on? Sion said, what IP camera did I mount in the PNP? It's not It's not small. Yeah, it's a large camera. It's just, in fact, what is it? What brand is it? I can't remember. But it's not a great solution. So what's going on at the moment, if I switch to, okay, I've really got to think about this. I want to switch to input, okay, I'm confused. How do I get to the security camera? So that is coming in on 7. Oh, 7, yes. Okay, this view. So this is all it is, what you're looking at right now is the HDMI output from my security camera system, which is mounted in the rack, and I've got a long HDMI cable that's currently draped around. It runs on the floor, around through the door into the clean room and plugged into the network, the NVR in the rack, and it's capturing the output. So I could be switching between different cameras here to show the different parts of the room, etc. But in fact, no, I won't do that. What I really want is a little, well, yeah, this is getting into a whole other subject, which is how do you put cameras in places, which is interesting, but where are we? I want that. And the focus looks way off. How is the focus through the eyepiece? Yeah, not particularly good. And also I need to zoom in a bit. There we go. How is that focus now? That's better. Okay. Now, sadly, this is probably going to take a little while because brightness is low. It's going to be a bit bright for you, but oh well. Now, what I really should have done is sat there and done this before the stream started, but I wasn't that organised. I was still screwing around with way too much solder paste coming out of this. It's flowing too well. Come on. It's going to make a bit of a mess, but oh well. Yeah, I was screwing around with trying to get the feed from the security camera so I could bring that into the ATEM. Get on there. And I really needed more time. I should have got up earlier this morning, but I was up late last night, so I didn't get I'm tired. I was working on some boards yesterday for a client, and then last night, when I should have gone home, I decided that I would do a little bit of construction work. Oh, get on there. And built part of the frame for a wall up near the mezzanine. And it's a bit hard to describe, but it's kind of the part of the wall that is directly above the rack that is in the clean room. Cleanish room. Missed that one. And that one. And that one. What have we got? Okay. I'm a fair way through it. Hopefully this won't take much longer. Don't even need to paste most of these. This particular thing. So one of the things that I did with this design was change from the classic ESP32, which is what I've been running, because I've had a Rack 32 doing this job since I've been starting to work on this machine. In fact, it's a Rack 32 that is currently running the machine, which is as I said, the classic ESP32. And this board has an S3 on it, which means that I can't just load the exact same firmware. I'm going to have to make some pin changes and things. So my goal, if I can pull it off today, is to have this board assembled and plugged into the machine, load the firmware and run the machine from this board. But that is going to be a big ask. Can I do that in 2 hours? I don't know. What have I missed? Oh yes. Oh no, there's no quick connector. There is a quick connector on the board, but I don't have the connectors, so I'm not going to paste that one up. It's not going to be populated anyway. What else is over here? Ooh, lots of filtering, power supply stuff. Missed one. This is really when I need text-to-speech because I can't see the chat at the moment. Got my head stuck on the microscope. Have I done them all? No, didn't finish the connector. The USB-C connector. I'm just going to be lazy and do that. Alright. Have I got the entire board? It looks like maybe I have. Oh no, there are a couple of spots that I've missed. Alright. I will do that. Yeah, doing this with a syringe is a pain, and it's far less accurate in terms of the quantity. I put way too much solder paste on some of these connections. Yeah, it's not very accurate in terms of applying the paste, but I hate cleaning stencils. So this is a quick way to do it. Now, all right. David said, came here for electronics, not cake decorating. I must be in the wrong location. Yeah. Yeah. Easy fix for me yesterday. They're replacing network switch and Cat5 outlets due to corrosion. Right. Stephen says, if you use the ESP IDF, they have a driver for the W5500 that works with their Ethernet and Wi-Fi library. Cool. Yeah, there's a driver that works on the in Arduino as well. Austin says, what about the 12.7 megapixel Raspberry Pi camera and Pi Zero as a video source? Yeah, something like that could be good. David said, pretty sure you missed a pad on one of the first ICs you grouped. Let's see. Yes, looks like maybe I did on the USB. Not USB. Yes, on the USB hub chip. Yes, text-to-speech isn't active. I know, it's not loading. I get a bad gateway when I try to load it. So it looks like there's something going on at Mitchell's end, and Mitchell isn't here in the chat to be able to ask about it. What am I doing? That's right, I was going to fix that. I will quickly fix this. I was saying that, yes, I'm going to need to, this whole thing is going to need rework anyway, so, and the solder, once it goes in the oven, sort of goops out and spreads and then sucks onto the pads. Right. Sion said, Pi Zero is not fast enough for a nice 1080. Pi Zero 2 is, but I don't have any spare. Yeah. The original Pi Zero was quite underpowered, like, sadly so. Now, next step. I'm going to be, okay, for this bit, I think I'm going to do a whole lot of running backwards and forwards. But before we get to that, if you have a voice assistant, I'm probably going to use mine a little bit today. Here's your fair warning to hit that mute button. Alexa, turn on the air compressor.
Okay.
Cool. Air compressor is up and running. So I'm going to switch to camera 7. All right. And I'm going to load the board from the back of the machine. So that view that you can see right now, to the right is the front of the machine, to the left is the back of the machine. That head is currently parked in the back right corner, and the PCB is sort of back left, like back left center. And what I'm going to do is, just because it's easier to reach, I'm going to drive, in fact I'll show you what I'm doing so that you can see what's going on here. If I switch to this view, I'm going to go into the feeder setup, and I'm just going to pick a front feeder, doesn't matter what, and drive. I'm going to click a button to drive the machine to its location, and you can see this is so what you see here, this video in the top, this is the live video view from the down camera that's mounted in the head of the machine. So if I change my jog distance to 10 millimeters and move to the right, you can see that the video is changing because the machine is moving its head sideways across the feeder bank that's at the front of the machine. But what this has effectively done is move the head towards the front of the machine. I'm just going to jog it to the right a bit more to get it a bit more out of the way. So I'm going to now go in there, and I think what I'm going to do is switch to this camera. I'm going to take the board in there and put it in the back of the machine. So moving over here, hopefully this is kind of approximately in the field of view, getting close. So this is the view into the back of the machine, and that's the board that I put in just to get the position right on the standoffs, which are a little bit loose. So I'm going to have to locate the board anyway, but at least it's got it into the ballpark. There's a bit of tape sticking up there. That's better. Okay. Now we are going to go back to, in fact, I think I can probably do this all remotely in a way that I can switch the cameras and you can see what's going on. So I'll leave that camera there. Head back into, I wonder if I can zoom in. I wonder if DroidCam will let me do that. Can I zoom? Yes, I can. Awesome. Okay. I think that is probably a little bit better. Yeah. That looks better. And what else? Now, oh, it looks like the text-to-speech is up. Go to loading. Come on, loading audio. Activate.
System connected. Activating the super house.
Yes.
Squirrel.
Awesome. Thanks, Mitchell. That's cool. Okay. So, what was I doing? That's right. Now, next thing I've got to do is, so that's the view from the front of the machine, from the security camera inside it. That's the view from the back of the machine. And I'm going to, what I'm going to do in the...
R said testing 123.7.
Yes, it worked. So I'm going to go to the board location. So you can see that the machine just jumped to the bottom left corner of the PCB, and looking at the view of the control system now, you can see that the mark is approximately in the bottom left corner. Not spot on, it's fairly close. You can see a fiducial up here. This is one of the location markers that allows you to set the board position more accurately. Now, at the moment, the calibration on this top camera is totally screwed. The millimeters per pixel or pixels per millimeter or whatever it is setting is way off. It's like off by a factor of 10 or something ridiculous. So I can't use the top vision on this at the moment to do automatic location, but I can do it manually. So what I can do is, in OpenPNP, it allows you to use any arbitrary footprint on your board as a fiducial. You can say, for example, that you want to use the location of a particular resistor as a fiducial. But what I'm going to do is select the 3 fiducials that are actually on the board. Then I'll go up to this operation here. So if I click this, it tries to run the automatic board positioning using the fiducials, but it'll fail because of the camera scaling. That's something I need to set. So I'm going to use the setting the location using placements. The placements I'm using are fiducials, but that doesn't matter. So I click that, it gives me a little blurb, go next. It goes to the location of a fiducial, and then what I do is jog the machine so that the camera is exactly over the center of that fiducial, as exact as it needs to be, and then go next. And then I'm going to jog the machine over this one. Yep, looks centered. Next. Jog over this one. Next, and finish. And now that has reset the location and the rotation of the board. So it should have positions for everything accurately now. So if I click a random part like diode 1 and then drive to its location, you can see that we're centered over diode 1. And if I go to, I don't know, pick a random resistor, this one, and drive to its location, it is centered over that resistor. So that looks good. I think we are just about ready to go. Okay, so I'm doing a quick mental checklist here.
Outside the box said we.
Yep. So before I click the go button, what I'm actually reviewing is how I'm going to switch this, because it's how many has it got? 46 placements that it's going to do. It's not going to take very long. So once it's running, it's probably going to take like a minute. I'm going to be switching between different views of the camera. So I want that view, which is the so that one is the user interface. That one is the view from the front. That one is the view from the back. Okay, I think we're sorted. So what I'm going to do is start from here, and I'm just going to click the go button. But what I'll do first is switch the camera view to bottom camera. So this is now looking up. This is the camera that is looking straight up. In fact, what I'm going to do before that is I'll drive, just for the sake of messing around a little bit, go to cameras, bottom, where are we? Position, and I'm going to drive, which one? What am I on? Camera 1 head. I'll switch to the first nozzle and drive the nozzle to its location. So what you see here is the view from the bottom camera looking straight up. This is the camera that it uses for checking alignment of parts on the nozzle. So when this job is running, I'm going to switch to this view probably a couple of times to show you what happens. And you'll see it detecting the part on the nozzle, drawing a bounding box, doing the calculation for the angle and the offset, and the everybody's saying to start. I will start, but this will be over so quickly that I want to be ready for it and explain what is going on. So this is looking up at the nozzle, and if I go to this, no, which view? Oh, I think I was on the wrong view. Yeah, so this is the view looking straight up. And you can see here that the nozzle is directly over the camera, and yeah, it's at the front of the machine. So back to the user interface, and I'm going to go back to the jobs tab. I've got one board in the job, and this is where it's all going to screw up. So I'm going to hit go, and we will see the machine begin. Here we go. So it started it's picking up its first parts, takes them to the camera and images them, and then it puts them down on the board. So if I now switch to the user interface view, you'll see it's just picked up a WS2813 LED. You can see it do the alignment on that. So you can see here it is imaging each of the components, putting the bounding box around them, and then calculating the corrections for the placement. So if we come back to this view, we can see that it is going to each of the feeders, picking up a part, taking it over the camera. Oh, it just failed on that, so it went to the reject bin, and then putting it on the putting it down on the board after it's done its correction. So we've already had at least one error. I could see in the user interface that what it did was pick up a resistor on its edge. So it rejected it and dropped it in that red discard bin that's at the front. What are we at? 20 parts, 21 parts, it's almost halfway through. Oh, that was another failure. So it went to the discard bin again. I wonder if it was the same part that it was failing on. So I'll leave it on this screen for a minute, and we'll see if there is a failure that we can spot. So far it's being successful. There's no nozzle changer in this machine. It's loaded with 4 nozzles, and the nozzles are all different sizes. At the moment, it's done all of the big parts, which means it's not using nozzles 2, 3 or 4 at all. It's only running nozzle 1, which is the one I use for 0603 parts and things like SOT23s. Like that one it just did. It just picked up a transistor or something. And now it's putting down some caps. Oh, these are 0805 parts. No errors. Okay, let's go back to this view. At the moment the machine is running at about half speed. This is, yeah, it's running I think at 50% speed right now. So it could be a lot faster than this. But what I need is variable control of the speed based on things like what part is loaded on the chip. OpenPNP has control for that, but I need to add, oh, it's done. Okay, so it had 2 errors. If we go back to this view, you can see that a couple of things to note. Down the bottom here, you can see placements 44 of 46. That means that there were 2 errors. There were 2 that it failed to put down. Oh, and down here it says job finished with 2 errors, 44 parts placed, 154 seconds, just over 1,000 components per hour. So yeah, it's running on the slow side. OpenPNP has a function where you can tell, if we go into parts, for example, you can see there is a speed column here, and currently everything is set to 100%. But the thing is that there are some parts, like, let's find something, like a worst case scenario, this thing here, the TS4550TP. This is a tactile switch. It's got a long stalk on it. It's one of those little plastic stalked tact switches that, a service mount type. And it gets picked up from the center of the stalk on the top, and most of the mass of it is actually really low. It's hanging like 5 millimeters below the tip and where it gets picked up. So to move this part, if you move it too quickly, you can just throw it off the tip. It'll fall off. So it needs to be run slower. But what you can see is that I've got 100% speed set on all parts at the moment, and 100% speed set on the machine. But what I've done in the OpenKayo converter is it's only sending slow moves to the machine. So it's running, regardless of what is set in here, we're sending a speed of about 50%. So what I need to do, one of the future things, is to extend the protocol converter to support the speed field. Right now it's ignoring it, and then I can do things like in here I could set, in fact I'll do it right now, I could set this part, oh you didn't see it, yeah, in here I could set this part to be 50% speed, and then the machine would know that when it has that part on the nozzle, it has to run the head at 50%. And when there's nothing on the nozzle, it can run at 100%, like do a rapid transit. And with many of the light parts, it could do a 100% speed as well. So for something like, I don't know, I'm just picking something. Where's something larger? WS2813, I don't know. Oh, SS56, that's got a fair bit of mass. So maybe that one might have to be run at like 80% speed. I don't know. That's the sort of tuning that has to be done over time to make sure that you're getting the most performance out of the machine while also hanging on to parts and not dropping them everywhere. So yeah, there's a whole tuning process you can go through. So this 1028 components per hour that we just achieved on this is basically like the bottom end. Like that's as slow as it would ever be, running half speed on everything and with full vision checks on everything, and yeah, and also not running as many nozzles as it could be. So if we come back to here, now one thing that you'll see is that error handling in OpenPNP I have set to defer on every part. Now there are two different modes here. You can have alert or defer. If it is set to alert, it stops the job immediately if it detects an error. So on those parts that are errored, it would have stopped and come up with a dialog saying unable to place part blah whatever, and then you can stop the job and discard whatever parts are on the nozzle and resume it, make it retry. But that's really annoying because it means you've got to sit here and babysit it, and each time an error comes up you've got to manually go through that process, which is actually the default behavior. But I change so what you can do is you can select all parts, come to set error handling and change the mode. So I set them all to defer, and what that does is it means that every time it comes up against an error, it simply moves on. It just takes a note of it, and then it gets to the end of the job and tells you how many errors it had. So what we can do now, in fact, you can see down on this column, there are little ticks in these boxes for the ones that are successfully placed. And you can see some of these parts are disabled, like these one, I haven't even, R13, R14, I haven't even defined what they are because I just don't have feeders for those. I can't remember what those parts are. We'll have to look them up because I'll put them on by hand. I think they might be 30 ohm resistors or something that was odd to this design. So I don't bother placing it in the machine. And you can see it's got a missing part here, it's just not defined. So what we could do is, in fact, I'm going to find where were the errors. It doesn't matter, I don't normally bother even looking for this. I'm just doing this kind of for the interest's sake. Oh, here we go. There is an error. There was an error here because you can see R7. It is set to be enabled. It's defined as something. What was it? 15K resistor. And you can see that it is not marked as placed. And there is a feeder ready for it. So it should have placed it. That would have been one of the errors. Now, so the workflow with this is that if it's had errors, all you do is click play again or start processing the job, and it tries to pick up anything that is enabled but is not placed. So if I do this now, it's going to try putting those two parts down again. So it's now just done one part, and oh, it's having trouble with that. Did it put that one down? No, I think it failed on that. I'm going to go, so that was the voltage regulator. That's something that I only just put into a feeder like yesterday or the day before, and that feeder is not working properly. So I'm just going to hit go on that again. Yeah, what's happening is that it is half advancing, and also I think the Z-axis is off. Oh, you can see it work that way. So what happens is it fails every second time, and it's because I wasn't paying attention when I set the feeder up. So the amount that it advances the feeder is half the pitch of the parts. I think it's advancing 4 millimeters instead of 8 millimeters or some stupid thing like that. But anyway, it picked it up that time. So now if we look down the bottom, you can see 46 out of 46 parts have been placed, and 46 out of 46 on the selected board. Because this, in OpenPMP, you can have multiple boards loaded simultaneously. You can do a batch job, which can even be a mixed job. You can have 4 or 5 different PCBs loaded at the same time. They can be totally different PCBs. They don't even have to be the same thing. Like, they don't have to be in a panel. They can have independent locations, and you can load them all in a batch, like in a mixed batch. So the selected board at the moment, we only have one board, and it is all placed. So, oops, the gantry is currently blocking the view of the board, but it is in there in the back. So what I'm going to do is, once again, just to get that gantry out of the way, I'm going to go into, let's just drive the nozzle to there. The point of doing that, I don't normally bother doing that, but the point of doing that is simply so that you can see into the back of the machine like that. I was just driving the gantry to the front. So now what I can do is go and grab that PCB and where are we? Yes, okay. I'm going to go and grab that PCB, and then we've got to figure out which parts have to be put on by hand, which looks like many, many parts, sadly. I wonder if I should have done 2 of these boards. No. So, switching to, what am I going to switch to? Let's go to that view. And see what parts I need to put on. So to do that, I need to open Fusion. Okay. While Fusion is opening, let's see what's going on in the chat. Oh no, Sion. Sion says, I wasted 1,175 by 15 by 15 RGB LEDs yesterday because I was rushing, thought I started a trial placement. I actually started a full panel build and the LEDs are rotated 180. Not fixable by hand. Oh, that sucks. Let's see if this one is correct. Yeah, my rotation is correct on that. WS2813 at least. That's a 50 by 50, which is a much bigger thing. And it could be reworked. Although reworking RGB LEDs totally sucks because the plastic that they are made out of, like that white plastic, the surround for it, it is basically like chewing gum. And as soon as you put any heat near it, it just bubbles and turns into a totally crazy thing. Yeah, Sion says, that's the problem with placing greater than 20,000 parts per hour. Yeah. So what we saw just then was placing 1,000 parts per hour. And so imagine that happening 20 times faster. And it would be Yeah. Wasted AP2112K, said Stephen. Yeah, I know, but they go into the discard tray and then I can use them. I place a lot of stuff by hand anyway. Now, what am I doing? What am I doing? Okay, that's right. I was waiting for Fusion 360 to open. I'm going to bring it up onto this screen in a second, and we'll have a quick look at what parts need to go on where. Oh, Henrik asked, where is the caps? I've got to put those on by hand. So, are you talking about these big ones here? Yeah, I don't have those loaded in a feeder, so I just put those on by hand. There are quite a few parts on this board. Because this is a little bit of an oddball board, it's got some things that I don't use on many other boards. I just don't have feeders. Yes, Michael, you're right. View T values. I'm just going to use. I'm just going to use this view at the moment and take a little bit of a walk around the board and see what I can find. Alright, what parts? There's a MOV. Yeah, so this next bit is basically just going to be Henrik asked, I meant, do you have them all? I should have. I hope so. I really hope so. So this MOV that's up in this part of the board here, can you see the cursor? Only just. Not very well. Yeah, that thing there. That is where, sitting up here, I'm going to need that. I'm going to need that. There's the MOV. So I'm going to, I need a producer or someone that can do like lots of camera switches and things. What I really should do is, maybe I should get a remote producer. So the camera views and all of this sort of stuff, it's all scriptable. I could set this up with a web control panel so that people could click buttons and change camera views. And then I could I could just do stuff and someone else could do all the camera selection. Okay, so that part we were just looking at was this one up here. That's the MOV. And I've got the bag of them here. So yeah, a few of these parts are going to be coming out of random little DigiKey bags because I have parts that I ordered for special purposes. Why did
Mitchell asked that we can link it to Steve for the mod.
Yep. Yeah, link it to Steve. All right, that mod is on. Now, what's this? Oh, those must be the polyfuses. I am moderately confident that those are polyfuses. And I have some here that are not necessarily in exactly the right footprint, but it's close enough. See? These polyfuses are physically a lot smaller, but we can make it work. What I should do is update the footprint on this for future. Yeah, these fuses are about half the size of the footprint that's on the board. Now I'm going to find. Oh, what have we got down here? Oh, that's right. This is the voltage regulator. On this one, because normally, recently, as you would have seen, I've been using the LMR38010. And for this board, I'm going to use, if I can find it, I'm going to use the LMR38020, which is the 2-amp rated version.
John, I can help with video production. I work in the TV film industry.
Ooh. Wow. That's interesting. Thanks for the offer, Amanda. So, what have I got? Yep, 2 amp regulators, and they require a different inductor. Now, what inductor was I using? Can we use for those? I don't know. I hope it's here. I think this might be it. What is this? 15 microhenry 1.9 amp inductor. Yeah, that'll do. I'm pretty sure that is the one that I wanted. This is a brand new packet, never opened. Yeah, so that's right. The point was that this is the 2 amp version of that regulator that I have been using recently. And that's because this is going to be supplying 5 volts to downstream devices that are connected via the USB hub. Which way around is that? I think that's right. So I wanted to allow up to 500 milliamps coming out of both of those USB ports, and I figured that if I went for the 2 amp version of that regulator, I would be covered, because then we've got power for our own use as well. And inductor time, but this is actually the very first time I have ever used this particular voltage regulator. It should work exactly the same as the LMR38010 that I've now used quite a few times, but you never know. What is that part? And why is there a part missing there? I think I know. I think that is... Ooh, this actually could be an issue. I don't even know if I have that. I'm pretty sure that's an oscillator for the USB hub. And it's possible that I have some. It's possible that I don't. But we can still populate other things. Alright, what have we got down here? I think these are the 30 ohm resistors. So, let's see what we've got over here. 30s, those are all 30s, yes. So we've got some 30 ohm resistors to put on there. Where's my handy dandy random resistor pack? Right here. 30 ohm, 30, do I can have 30 ohm? Yes I do. 30s. I'm making a right royal mess of things. This is, yeah, I am now out of feeder slots in that first KO. So, yeah, I ended up buying some Yamaha CL feeders. Although they're not genuine Yamaha, they are clones from, oh, there are some parts there that I know what they are without even looking them up. These ones here, the 5K ones. So, yeah, I've had 5K ones loaded in a feeder previously, and I hadn't used them for projects for a little while, so I took that feeder out and replaced it with some other thing that I needed. What else have we got to put down? That doesn't get done now. Oh, there's a reset button. The snoot button has to be done. I need to find the TUSB USB hub, which I am pretty sure I do have that in a convenient spot. Right here in my PCs. This is my organizational system for random cut tape. I have anti-static bags, each one labelled with one of my labels with part numbers on it for DigiKey and LCSC and barcode, so I can just zap the thing and it takes me straight to the product page for that particular thing to reorder it. And then I stick on labels from whoever the supplier was, and I have a category. So the sticker at the bottom says what box it goes in. I probably should be doing this, shouldn't I? So the sticker on the bottom says what box it goes in. So this is ICs. And the box matches the Eagle library for those parts. So it's all categorized. So I can, if I'm running low on something in this, I have a barcode scanner, and all I do is zap the barcode and it takes me to the product page so I can reorder from DigiKey or whoever the supplier is. So what was I looking for? I wanted the USB hub. There we go, USB hub controller. Now somewhere there should also be in the oscillators box. There should also be an oscillator to match this. Is there? Ooh, is this it? Is a 48 megahertz MEMS oscillator? I don't think that is it. What am I needing? What do I need? We are looking for this, which is, it is 48 megahertz. What's the part? 48 megahertz. Seriously, that is, okay, my library. This is something that came in from a very old project that I didn't do. SOT 753. Yeah, I'm pretty sure that is the correct one. So let's check that. Let's see if that really is a SOT 753 footprint. And I'm just going to, if it looks like it matches, I'm going to take it on faith and just stick it down. But I can't believe that in the design I don't actually say what the part number is. It just says 48 megahertz oscillator. Great. Yeah, that looks like the one. Now there's some other part that goes just above it as well. Yeah, this particular part of the design was cribbed from a project from years ago working for Albot on the telepresence robot project thingy. Now, what is above it? 1.5K. Oh, okay, it's just a resistor. Nothing special. It's just something to do with the setup. It's like a reference on the USB hub. So, back to 1.5K. And that goes where? There. I think that's where it goes. Then the USB hub. What I should do is go and start warming up the reflow oven. It takes a while to warm up. Boink. Switch tweezers. Switch to these ones, curved ones. It's easier for picking up these sorts of parts. Come on. Oh, come on. Easier from the corners. Boink. Normally I do this under the microscope. But is it blinking? Oh no, it's kind of working at the moment, so I could actually be doing this under the microscope. Let's see if this looks alright. I'll just get a bit of... I'll zoom it out. It's a bit too far in. And get a bit more focus happening. Ooh, 1 hour in? I think that means we are 1 hour in.
1 hour remaining.
Yes. Alright, we're at the halfway point and we're just about ready to put this in the reflow oven. Which is kind of slow, but I've been faffing around. Alright, look at this. You can see the tiny little fuse sitting on the footprint that's way too big for it. Ooh, there's the snoot button, so I need to put that down. There's the SP32 S3. There is a diode missing from here. Now this is going to be really interesting to see what happens with this. Let's chuck that diode down right now. Grab my diodes box. what am I looking for? Solid 1, 2, 3. So I want in 5819. That'll do. This is just to make the WS2813 run at 4.4-ish volts instead of 5 volts. There we go. I don't want it to run at 5 volts. It probably would. It'd work, I'm pretty sure, to have VCC at 5 volts and to be driving it at 3.3 volts. It does work on modern revisions of the WS series chips, but I can't run it at 3.3 volts because I want its output to drive other chips, other WS, which could be a WS2811, which does not accept 3.3 volts on its logic input. So I need the output of, where are we? If I can find it. Must be close. Come on. Oh, it's down there. Okay, so there's a WS2813. I want the output from this LED to come to this header and then be able to drive other things with a logic level that is in spec for a 5-volt device. So that's the reason that I'm doing this sort of halfway trick. So I'm not running, I could run this at 3.3 volts and drive it with 3.3 volt logic, but then I would only get 3.3 volt logic coming out of it, and I want 5 volt compliant logic coming out of it. So that's the reason for doing that stupid little trick. Okay, now, oh, that's right. Let's go and turn on the reflow oven. So I'm going to switch to that camera because I'm going to go and point it somewhere different. I'm going to point it here. Somewhere like that. Hang on, I've got to go back into the other room. Oh, no, I can do it from here. Let's see if I can check the field of view. Zoom out. Okay. Now, the reflow oven, so down here, I recently filled in the corner and I built the landing for the top of the steps, which means that the exhaust, that's fallen off, and the power cable for this can no longer just go through the big hole that used to be there. The exhaust now goes up through the ceiling, but the 3-phase power for the oven is right here. And in order to run it, I have to drag the cable out the door and plug it into the 3-phase outlet, which is just out here. So, get that in, screw it on. So obviously that is something that I have to fix. It's no good having to do this and leave that door open a little bit. I'll get the oven on, set the profile, go. All right, the oven is on and warming up. Scott said, time to mount some outlets in the ceiling. What I'm going to do is run that 3-phase cable up through the ceiling beside so if you're looking at that view right now, you can see the silver exhaust that comes off the top of the oven. It goes up through a hole onto the mezzanine area for an extraction fan, and I'm going to run the 3-phase cable up to the ceiling as well, and then along above those beams. Instead of, so the exhaust is hanging below the beams, I'm going to run the 3-phase power above the beams, and then up through at the wall on the back of the mezzanine, and then connect it to the 3-phase up there. So, where am I? That's right. Oh, I'm going to go back to here. What I needed is these big caps. I need the snoot button, the piezo, the ESP32 connector. Alright, I can do some of these things now. USB connector I'll put on. So I'm doing this in reverse order of height, or no, more accurately, reverse order of stability. Because as the board is moved around, these parts can fall off. So that one is fairly stable.
Good reason the exhaust isn't up above the beams.
Good question. So Scott asked, any good reason the exhaust isn't up above the beams? The reason is just that it doesn't fit. I could possibly make it. No, I couldn't. If we go back to this view, the gap above the beams, so you can see that there are the white beams running across, and then there are the silver beams running lengthwise. Those silver beams are, I think, 70 millimeters high. So the gap above the main white beams is only 70 millimeters. It kind of looks bigger in that view, but it's not. It's fairly shallow. And the exhaust duct is about 150 millimeters thick, so I'd have to flatten it to get it going above those. Okay, Stephen, last parts. So I need the snoot button. I will go and grab the snoot button and the caps, which are both out in the other room. Where are the buttons? Where is that button? Oh, here it is. Alright, I've got a snoot button. I need to grab 3 of the big electrolytics. Where did they go? Oh, I think they might be in the front room. I need to grab the ESP32 S3 module. Right, there is the snoot button. There's some caps. In fact, what I might do is use up. I've got some old caps here. Oh, here we go. I'm going to use up these caps because they're not going on any other boards. Then I need the S3, which is right here. S3, yes. There's a big strip of ESP32 S3 modules. How many is in there? 100 in the bag, I think, something like that. Only need one. Then we should be getting kind of close. Kind of close. Alright, snoot button. Oh yeah, the piezo is the other thing I need. I'm going to risk it and put the S3 module on now. That alignment is probably off. I just plonked it in place and didn't even pay that much attention. But I will check that before it goes in the oven, because it might get bumped anyway. I'm going to put these on last because they are the most likely to be knocked. So I'll do the piezo next. And these piezos have a tendency to melt in the reflow oven. So what I'm going to do is chuck some Kapton tape on top of it.
You're not sure if there are some empty pads near Steve's head. It's hard to see.
Some empty pads near Steve's head. Ah, I think you're right. Well spotted, Aaron. I am leaving a big mess of bags on my bench. They'll have to be cleaned up later. Yes, well spotted. You are right. I will get back to that. So I've got this little piezo unit. but they dislike the heat of the oven. So this is my somewhat dodgy solution to that problem. I'm going to grab a little square of Kapton tape. Come on. Come on. Grip it. And stick it on the top of the piezo like that. So that now has Kapton tape on the top of it. And then I can chuck that on the board. And then after it's reflowed, move it back in view. So after that's reflowed, I can then peel that Kapton tape off. Alright, now let's find out what these two parts are. They're something related to the they're something related to the USB controller. Where are they on the board? Near Steve's head. It's these two here. 30R. Oh, it's a couple more 30R resistors. So let's chuck those on. 30s. Oh, Alexa, please turn off the air compressor. I muted it. Alexa, turn off the air compressor.
Okay.
That's better. Now how are we going? We've got, I think, everything. So now it is time for putting on these caps. So I've got an entire reel of these electrolytics, and I don't use them anymore because I bought them for a customer project, and then we switched to a different cap manufacturer that had the same, that basically better spec caps. We switched to ones that were mechanically lower, like physically lower. They weren't as high, and they had a longer operational spec for the temperature, for the max temperature range. And it was in a situation where we really cared about reliability. So we went for some really good quality, expensive electrolytics, and I've ended up with almost a full reel of these just sitting on the shelf. I think now I need to take this and switch to where am I? I'm trying to figure this out once again. Camera 8. That's the one I want. And then we will put this through the reflow. And I'm going to try to carry both the board and the camera at the same time. And this is the seasickness warning for everyone. Bringing it down here. There. Okay. I'll try to do this without dropping the board. Okay, there it goes. First board going in. You can see it slowly moving in on the conveyor. And the controller, the 32-year-old controller, which is operating in Fahrenheit. You can see zone 1, zone 2, zone 3 temperatures, and the speed. It's a bit bizarre because this is a German-made controller that is in an American reflow oven that was made more than 30 years ago, and it's doing. It says 0.2 feet per minute speed. That is totally wrong. It's actually, I think, 0.2 meters per minute. But the temperature is in Fahrenheit. It's a bit of a mixed bag. So I'm running program 12 on it at the moment. Now, I'm going to try, what am I going to try to do? Maybe lower this, can I? No. Sorry, I'm faffing around because I don't really know what to do with the camera. This process is going to take a while. Maybe what I'll do is I'm going to take the camera around. See if I can move it around here without bumping the bottom of the tripod into anything. There you can see. There's Mick'll Make It sitting in the corner with most of its feeders missing. Alright, slowly moving the camera around. And I'll put it down here at the exit point. Then I'm going to go into the other room. Is that it? Yes. Okay. Zoom in a bit. There we go. There's the exit of the oven. So I'll go back into the other room. And what's this? Okay. Back to the chat. Let's see what everybody is talking about while I've been away from the screen. Alright. Aaron said, is there a reset button to be placed or is that a through hole? Yeah, that's a through hole. I think I've got everything on the board populated. We need a safe word. Curtis says, I thought you were going to check component alignment before the reflow. Yeah, I was. But I kind of didn't. Oh well. Yes, Austin says, we did the math long ago, but the machine is in yards if I remember correctly. Yeah. Yeah, I think you're right. It is yards per minute on the feed rate for the conveyor. Chip wants to know about the pizza. Wagon loads. Oh, you made it just in time. So the board is going through the oven. What we are looking at right now is the exit of the reflow oven, and in a few minutes. I think it takes about 7 minutes. I can't remember. 6 or 7 minutes, something like that, for the board to go through the oven. And in a little while, we will see it start to come out that exit. Now, in the meantime, Leon! Leon, thanks for coming along. So I've got a mess on my bench here to clean up now because I've got all these parts bags and things that I've pulled out.
The next project, Open Oven, convert old yards display to a nice touch screen with presets, etc.
100%, Aaron. Yes, I have been thinking about that. And in fact, I almost was forced into doing that maybe a month ago, because the oven stopped working and it was the controller. It turns out that the controller had blown a fuse and I didn't, so I basically replaced the fuse and it worked again, but I don't know why it blew the fuse. And what I was thinking of doing was a project to put in. And the thing is that it's very simple. Controlling the oven is not hard. It's some SCRs that are used to control the heating elements for the different zones, and it's got some thermocouples. So, and reading those is not hard. So I could build a controller, and I was thinking it would be really cool to make a touchscreen based controller, maybe using something like one of those WT32 SC01 ESP32 based touchscreens. It'd be nice to have something like big and fancy looking, but not really necessary. Just something like a 4.5-inch touchscreen would be nice, and it could show temperature plots and things and report to MQTT. So basically like a multi-zone version. Well, no, it's a bit different to Xeon's Reflow Master Pro. Oh look, here comes the board. I'm going to run in there and grab it. Yeah, it's a little bit different to Xeon's because Xeon's controller is for fixed devices that run, they take the total volume of the oven and bring it up to a temperature and then bring it back down again. Whereas this is different zones, and each zone has to be held at a certain temperature. But in terms of the control system, like what it does, it's basically the same thing. It's reading from temperature sensors and driving heating elements. So yeah, with a little PID loop or something. Yeah, I probably should have paid more attention to the alignment of the parts, but it'll be okay.
Austin_creations said WT makes a larger 4-inch square variant now as well that uses the same IPS display as the Plus version.
Yeah, that would be really cool. I should check that out. Have a look at their larger display. Yes, my bit rate is very low today on NBN. Just making sure these are all attached. Okay, time to chuck this under the microscope and check alignments and do any rework. I am pretty sure I'm going to have to do rework around the USB connector because I was just squirting that solder paste on with crazy abandon. Let's go to this view, and which tweezers should I use? Where are my rework tweezers? I've got 3 different sets of tweezers here on the bench, 4 actually, and none of them are my rework tweezers. Oh, which are out here. I use different tweezers for different purposes, depending on how much I care about the thing. Oh, great. The microscope is flickering again. That is so annoying. Once I get... Yeah. I need to buy another camera. Alright, so, quick scan over the areas that are likely to be okay. Yeah, you can see there's some misalignment here on the module because I didn't even look at the alignment. Oh, stop that flickering. Come on. I'm giving it some of the percussive maintenance and it doesn't seem to make any difference. Oh, I thought it'd stop for a moment. Anyway, you can see it's misaligned. It's not misaligned enough to actually be a problem. So, it's fine. I don't care. There are no solder bridges. Ooh, has that one... What's going on with that? It's probably joined underneath. In fact, I could buzz that out just to make sure. But I could just rework that. Alexa, turn on bench 1.
Okay.
Yeah, it is soldered through. You can hear the beep then. That looks kind of dodgy. These 2 pins, but I think that's actually okay. There's a solder bridge here, so let's fix that. Might as well fix whatever I find as I'm going. I might have to take that microscope off the screen. In fact, I'm going to do that because it's flickering so much that it's just going to drive people crazy, I think. I'm going to switch to... What do I do? I'll just switch to the front camera and turn my double self off. No, that's not very interesting. Let's go to that view. At least there's something on the screen then. While I do this rework, I want to be able to show the rework, but if the camera is flickering that much, that is rubbish. Alright, so I fixed that solder bridge. What else is going on here? Is there anything out of place? What does the USB-C connector look like? Amazingly, it looks alright. I can't see any solder bridges in there. How did that happen? How on earth did that work? Oh, there are a couple of pins that aren't connected. The solder didn't flow under them properly. Are they pins that matter? I don't know. No, anyway, I fixed them. And I'll add a little bit of solder to... where are we? One of these ICs. Oh, no, one of these big caps. Yeah, as soon as there is a little bit of extra in my account, I'm going to order a camera. I'm pretty sure I actually have a camera listed on AliExpress open in a browser tab somewhere. A microscope camera to replace this one. Is that everything? I think it might be. Okay, so in a second I'm going to start putting on through-hole parts, which you'll be able to see through the overhead camera anyway. Don't need the microscope for that. Just touching up a couple more joints on the USB hub. Okay, I think we're sorted. Oh, I'm just going to buzz out a couple more connections on the poly fuses. Yep, they're all connected. And back to overhead. So, what do we need? We can connect USB. Maybe one of the first things I should do is just connect USB and see if that works okay. Because I can do that without even putting any other parts on. Where am I going to get USB? Over here. Okay. USB cable on an extension lead plugged into my computer. So let's just plug this in, see if anything goes boom. I'm not even bothering with the with testing, like running it up on a lab power supply yet. I'll get to that when we get to testing this portion of the voltage regulator. You can see the blue power LED has come on. Let's just check the 3.3 volt rail. And what am I getting off that? Where do I get that? That'll be ground. That'll be 3.3 volts. And I'm getting 3.3 volts. Beautiful. So the 3.3 volt regulator is working at least. So we're getting 5 volts coming in here off the USB connection. And what could I do? I could just load like a test thing for the LED. Let's do that. Oh, Johnny said, just realised I have a heart in this chat. I don't in other live streams. Yeah, I don't know what the heart does. Yeah, Scott says, too bad there's no way to put the meter display on screen. Yeah, hang on. I'm going to see if it works. I've got UT61 overlay. Oh, I don't have that plugged in. Where is it? Where is it? I don't have USB plugged into the UT61 module right now, so it's not getting power. But I'm pretty sure I can fix that. Let's see. Let's give it a try. Power that up. I don't know if the node red portion of it is actually set up right now. It may not be. So I'm just messing around in OBS seeing if the UT61 overlay comes up. Come on, can I edit it? No, UT61E is... Oh, it's on the wrong node red instance. Oh. 185. Aha! There it goes. Do we have values coming though? I suspect that what's happening. Yeah, that's a squirrel to chase another time.
30 minutes remaining.
That is a squirrel to chase another time, because what's happening at the moment, if I switch, I'm just going to switch to camera 8 and you're going to get a green screen sort of thing. So this view is showing the green screen composition with the overlay but it hasn't. The chroma key is not pulling out the green at the moment in the ATEM. It's not set up to do that, and the actual adapter is sending to the wrong node red instance. So I need to fix that, but that'll take a little bit of time to fix. So I'm not going to do it right now. What was I doing? That's right. I was looking for a way to start doing some basic tests on this board. So I'm going to go to examples. I'm in the Arduino IDE at the moment. Oh, come on, examples. I'm just going to use the Adafruit NeoPixel. Where are we? Simple will do. And let's see, stick this up on the screen. Now I want, what have we got? SP32S3, that'll do all of that. We've got port, oh, it's not plugged in. Okay, oh, hang on, it is plugged in. Oh, maybe the USB hub is not working. Okay, that is interesting. Port, we're not seeing anything. Alright, so what should be happening now is if we switch back to this view, so I might have to do some debugging of the USB hub at this point. So we've got the upstream connection here, which is the USB-C connection, going to the USB hub, which is this thing here, and then downstream, that is going to 3 places. It's going to, oh come on, it's going to the 2 auxiliary ports, and it is going to the onboard ESP32S3. So to communicate with the S3, we have to go through the USB hub. And if that USB hub is not running, then we can't talk to the S3. So, first thing to do is see whether this USB hub is actually coming up on my computer as a thing, if it even exists. And this is the oscillator, so that is something I need to check as well and see if the clock signal is on here, which I can do with the oscilloscope. Maybe that is one of the first things to try, but no, before doing that, what about if I go into, can I find out in About This Mac, more info, and I'm looking for USB stuff. USB displays, name, chip, coverage expired. What is coverage? Oh, okay, is that like, yeah. No, not About This Mac. How do I get to look at USB devices? I don't even remember. It used to be that if you went into more info, there was like a system profile thing. Let's go to USB. Nope. Someone will be telling me in the chat how to get there. Storage setting. Oh, system report. This is it. That's what I was looking for. Thunderbolt USB 4. What? No. Where is there just a?
Scott Miller says open a terminal and type LSUSB.
LSUSB. Yes, good idea. Let's do that. Terminal time. LSUSB. Okay, that's no good. Where am I looking? Oh, just regular USB. Okay. Let's see what's in the device tree here. So we've got hub. I've got this hub plugged into another hub. Right, which one is this? It's not that one. Oh, no, not that one. It'll be a USB 2 hub. Could be this one. AS Media Technology. I don't know. capacity 2 terabytes. No, that's the external controller. I'm just going to unplug. Where am I? Here's the cable. I'm going to unplug this cable and see if anything goes away. Nothing goes away. Or do I have to come out and go back in again? No. I think it's not enumerating the hub at all.
Mitchell R said unplug the device and see if anything changes.
Yeah, that's what I just did. So I've just plugged it back in and nothing changes. Alright, so the USB hub is not enumerating at all. So I think there are a couple of things for me to check. One is this clock signal here. I want to see if this 48 megahertz oscillator is actually oscillating. That is where show clock. Where is the clock signal? There we go. That is the clock signal out of the oscillator right there. So in theory there should be a 48 megahertz square wave on that. And I'm tempted to go and grab the other camera. I'm going to do it. I'm going to get the phone camera thingamajiggy. Oh, forgot to turn off the oven. Turn off. Sitting there chewing up power with nothing in it. This is a very nasty, crude way to be doing this, but let's see if I can point. Come on, wake up, phone. Come on. I'm trying to. Droid cam is not waking up.
Would it still enumerate if the S3 chip isn't in download mode when being powered up?
Yes, it would. So what should happen is we should get enumeration from multiple devices. So my camera is not working. I don't know why not. Maybe it just went flat. Hang on. This. Oh, it is working. Okay. You can see the big mess of the bench. All right. In a minute, I'm going to. Come on. Can we adjust that? That's a terrible picture because it zoomed way in. But let's see what's going on here, if anything. Leads falling everywhere. Get up there. That's better. Run. Turn off channel 2. What are we set to? 1 volt. That'll do. 1 volt range. And where can I grab a ground? Many places. Ooh, there's something happening there. Hang on, I've got to get a ground that's actually properly clipped on. That was just me pushing the probe against the shield of the USB connector. So I'm going to grab that on there, change our, what are we doing? And that is the oscillator signal, I guess. That's probably okay. I was expecting a square wave. What does it say that we're at? Frequency, 48 megahertz. Okay, so we've got a 48 megahertz clock. That is remarkably unsquare wave-like. But maybe that's fine. I don't know. Yeah, I just don't know. So, yeah. Well, we have a clock. It may not be the clock that it needs, but we have a clock. So let's go back to overhead cam and see what else we can investigate. What to look at. Alright, well I suppose the next thing is to just do another quick visual inspection around the chip itself in case I did something stupid like put it on backwards or something, some obvious problem. And even though this is flickering like crazy, I'm going to switch back to microscope view and have a look through here. So what have we got? No more solder bridges. I'm going to, just for the sake of it, I'm just going to, because these joints look pretty crappy, I'm just going to do some rework on this. Squirt in some flux juice. Make sure these joints are all good. That soldering iron tip is nasty. Needs cleaning. Alright, try now. Needs a bit more solder, I think. That's better. Yeah, they came out looking quite inconsistent with these solder joints. Ooh, bridges. And this one. What am I hitting? Oh, it's outside. I've got to come in from the other angle. It's outside of the field of view of the microscope, but there are big capacitors there, and they were just bumping into my soldering iron. Get off there. Come on, solder. Get off there. Are you going to make me resort to the solder wick? I think you are. That's better. Okay. It was slightly over-endowed with solder. This side still looks like crap. That's shameful. Let's clean that up. A little bit more on there. Bit of a drag. I keep bumping the end of that cap, so that looks ugly now too. Okay, so we've got the oscillator is oscillating. The IC orientation, where's pin 1? I actually can't see the marker.
People have said something silly, but maybe swap the USB cable around. I remember some USB-C cables ports are weird with data.
Yeah, that's worth trying, definitely. That would also catch problems, potentially, with wiring of the, where is pin 1? Yeah, with the solder joints within the thing. So, where's the marker? Oh, there it is. Okay, so the pin 1 marker is down in the bottom left corner. And I'll just make sure on the overlay that it really is pin 1 on the bottom left corner. So yeah, it could well be soldering in here as well. Like it could be that data pins on one side are connected but not the other.
Alan Knox said check the USB connector soldering.
Yep. Let's come back to here. Looking at, what are we going to look at? Plugging that in. Now on my computer I'm going to go back to system information. Nothing has appeared. So I'll unplug this, turn the connector over, plug it back in, and nothing has appeared. So far we're getting failure on that. But let's just do a quick check on orientation. Yep, marker is in the bottom left corner.
System notification. 15 minutes remaining.
15 minutes. Okay, I have oriented it correctly. Now, I need to check for like really, really stupid things because I wasn't paying that much attention. Let's have a look. For example, this part. Because we were looking at different USB chips when we were talking about the design of this. Oh, come on! I'm selecting the tool. Fusion, you piece of shit. This is the view tool. Info. Okay. TUSB 2036, because we were talking about different variations of the USB chips. So let's do a quick sanity check and see what I actually put down. That one. TUSB 2036 VFR. Yes, VFR. That is indeed what I just put down. I didn't put my phone in silent. I did put my phone in silent. Why is it ringing? I don't know.
Knox said public service announcement. Our apologies for the host profanity. He's normally well behaved.
Yes. So I've got, okay, so that's the USB chips. And so it is the correct USB chip. Now, one thing I should check is whether that is the correct oscillator to be using on here. Because this oscillator may have come from a totally unrelated project. Now, the way to check that is I need to look at a very old design, which, just looking at what's up on the shelf, there are, where is it? There is a client project for our bot. I have a feeling that I might have even taken that box like upstairs onto the mezzanine. That's where that project came from originally. I don't see it. I don't see the box. So I think I'm going to... Okay, a couple of things we can do. One is I can do a search on the data sheet for that and have a look at what that clock is meant to be. I am just about at the point where I need a drink because my voice is failing. And now, what is the spec of what is the spec for the oscillator? Alright, sorry, I keep getting distracted because I have a customer who keeps phoning me and messaging me. And I keep seeing it popping up in my field of view. I'll have to follow up with him after the live stream. So where are we? So all detailed, downstream port, front feature description. Now the other way to check this, in fact probably a better way to check this, is I'm going to launch Eagle and okay, so Eagle is opening. Just going to pull this down to here and find the original project that this came from, because I think it's the same oscillator, but I don't know for sure. I might be totally off track here. It may not be anything to do with this, but this is the avenue to investigate right now.
Aaron Knox said, stupid question, but that USB-C cable is plugged into your computer and not a wall wart, etc.
No, that is a good question. It is indeed plugged into my computer. It's plugged into a USB extension cable going into my computer, and it's the floating USB cable that I have on the bench in front of me all the time that I use when I'm working on boards. So it was just plugged into a different board, and that was working. And now, where are we? I've got to find... Yeah, this is a really old project. So I'm searching back through. It's not even in my clients folder. It's in projects. What would it have been called? Could it be in the archive directory? Maybe. I could be... Oh, was it called Neck Hub or something? I've got so many hundreds of projects in Eagle. It's ridiculous. And it was done for a client years ago. I know that we did find this when we were going through the design part of this project. USB.
Stephen W. says go to page 15, typical application circuit.
Oh, cool. Thanks, Stephen. Yeah, I think I'll do that. At the moment, I'm just kind of scrolling through projects in my Eagle directory, trying to find where this hub would have been. USB. No. Don't know. Okay. Page 15. Let's have a look at what page are we on? 6. Keep going, keep going, keep going. Page 12. I'll go up to page 16. Typical. Oh, okay. No. 9.2. Yeah, that is page 16. Detailed design procedure. Got the... Hang on, why does it say 6 megahertz clock signal? That's interesting. So maybe it needs a 6 megahertz clock, not a 48 megahertz clock. But let's find out. Alright. Where? No, that's on the packaging, that's past it. Back up here. Where is the typical application circuit? Crystal. Oh, okay, no, it provides the flexibility of using either a 6 megahertz or a 48 megahertz clock. Logic level of the mode pin controls the selection of a clock source. When mode is low, selected to drive the internal core. When mode is high, select the input source. Internal oscillator cell is also powered down. For 6 megahertz requires a signal on that. For 48 megahertz, okay, here we go. For a 48 megahertz operation, the clock cannot be generated with the crystal, using the crystal to output, etc., etc. Uses that, while that. When the oscillator is used, by connecting its output to the crystal 1 pin and leaving the crystal 2 pin open, its output level cannot exceed 3.6 volts. So how do we tell it that it is at 48 megahertz instead of 6 megahertz? I don't know. So, logic level of the mode pin controls the selection of the clock source. Mode is low, it's internal. When mode is high, it's selected as the input. So we want mode to be high. Very good. Where is the mode pin? Mode. Zoom. Mode is high. Okay. Here we go. There is the mode pin, and it is connected to 3.3 volts. Okay. That seems acceptable. So it should be in, and it said to keep crystal 2 floating, which it is. There's nothing connected to crystal 2. So I think that our clock source is okay on the USB hub. So the next thing to check is signal paths. 5 minutes. I think
System notification. 5 minutes remaining.
5 minutes remaining. All right, what I need to check is that I have a signal path from here. So we've got USB negative and USB positive, and we want to make sure, firstly, that they are not shorted together, and secondly, that they have a complete valid path all the way through here, coming up to this point. And what we should have is 30 ohms of resistance, because we've got these 30 ohm resistors in series, and then it's got these 22 picofarad capacitors here, which are actually 15 picofarad capacitors. I hadn't mentioned that earlier, but that could be an issue as well. So what I want to do is make sure that I've got a signal path with 30 ohms of resistance between that point and that point.
Stephen W. says we already checked 3v3 was present, right?
Yes, we did. 3v3 is present, at least, but that is a very good point. That is worth checking. I checked that it was present here. I put the probe on this track, on this pad of the ESP32, and 3.3 volts is definitely active there. But what I should do is check that we've got 3.3 volts down here also on the hub chip. So I can do that on the bottom of this capacitor right here, and hopefully that will show me. So I'm gonna just do that off camera, unfortunately, but I will just do a quick check. Do I have 3.3? It says 3.296, which is close enough. Okay, so we do have 3.3 volts. So what I'm going to do now is check the signal path. So I'm going to unplug power from USB. I'm going to check the signal path from the pin on here on the back of the USB connector. That should come through. It drops down with a wire and then goes through and then comes back up again. And these two resistors here that you can see, the vertical ones, they are the 30 ohm resistors that then pass through. These are the two capacitors that should be 22 picofarads, but they're actually 15 picofarads coming through onto the input side of the chip just here. So let's check whether that signal path is valid. And I'm going to, I've got the multimeter in resistance mode, and which of these ones is sharper? The positive pin is sharper. Alright, so doing this, I really need to do this under the microscope. In fact, I'm going to switch to the microscope temporarily, even though you can't see it, because I'm going to do a short circuit test between the positive and negative, just to make sure that there is not a short going on. 0.68 ohms. What? Yeah, okay. It looks like there might be a short in here. There could be, it could well be that there is a short. Hang on, let's go back to here. So it's flickery, but I am reading 0.68 ohms between the positive and negative sides of here. That could be because of stuff going on inside the chip here, but it's probably not. So the likely explanation is that down, I've got to get the position right, there. Down inside here somewhere, there might be a bridge, a solder bridge. So I am going to just squirty some flux in there, and just do a little bit of heating of each of the pins in here. And if there is a solder bridge, this may well be enough to clear it. I'm doing all the pins, even though there are really only 4 pins that are involved in this part of the circuit. And let's try again. So I'm going to probe between, now there's flux everywhere, I can't even see. Between there.
System notification.
Where?
Screen is over.
there and there. 4.7 mega ohms. There and there. Oh no, I think I might have been probing the wrong pins earlier, which is why I was seeing it as a short. Okay. Back to the overhead. Plug this in. I don't think this will have made any difference, but I'm just going to switch back to System Profiler and this, and it has not yet appeared. Alright, we still have nothing. I assume that this will live update if something changes. Maybe it won't, I don't know. I just went out of it and back into it, and we don't have anything else magically appearing on here. I've just unplugged it, plugged it back in. Nothing is changing. Alright, so we have no enumeration. Alright, so that was a short circuit test. I'm going to do the resistance test that I was talking about earlier, for the continuous circuit test. So I'm going to put this over here and check. So what I should have, now this is going to be really hard doing this without the microscope, but if I make contact on this side of the capacitor, I should see a 30 ohm path if I get the right pin on the back here. I do, that's a 30 ohm path. Okay, that's good. Now if I do the other capacitor, I also get a 30 ohm path. Well, that kind of sucks, because that means that there's no problem there. I'm getting 30 ohms between this point on the back of the connector coming all the way through to this point here where the track goes to the USB hub. So, what else to do to make this USB hub enumerate? What else is there?
Aaron Knox said swap out the USB chip.
Yeah, just replace the chip entirely. That could be worth doing. Let's see. Yeah, it's kind of grasping at straws. Just replacing the entire chip. It's possibly worth doing. But what I would like to do is find the project box that has the USB hubs in it that I made previously, like the ones that I made years ago. It's got I know that those ones worked. It had the correct oscillator, it had everything functional. So that way I can just verify that what I'm using is correct. Alright, I might take you on a little magical mystery tour, which is, yeah, why not? It's kind of, I don't want to do this because it's kind of embarrassing, but I'm going to switch to this. I'm going to switch to this camera. Zoom back out again because it was zoomed way in. Alright, we're going to go for a little walk. We're going to go in here, through the clean room. What? Oh, maybe it's up here. Is it up there? No, it's not. Okay. And out the back, where the cable runs, going up plugged into the three-phase outlet. And I need to vacuum up some sawdust up onto the mezzanine. So what you can see up here, this is where the exhaust comes out from. This is the extraction from the reflow oven, and this whole wall I've just started building. That wasn't there. Yeah, until just now. So I've just been framing up on that. And then the actual extraction fan is going to get mounted here somewhere, and then some more duct will come up and run along and go to the big extraction system that runs extraction for the whole factory. So if I back up and around, I just bumped my head. You can see part storage and random things. There's a packing bench. There's my little lounge room up the far end there. And somewhere in among all of these boxes is where I hope I've put the project box for Albot. But so far I'm not seeing it. Well, if I point the camera at things, other people may see it. But right now I'm nowhere near the computer. I can't see the chat. I can't hear the thing. Okay, so Mycroft, no, I don't know where the Albot box ended up. Maybe I ended up repackaging it into a smaller thing because I didn't need, like that company doesn't even exist anymore. That was Marita Chen's robotics company, and she wound it up before she moved to the US. Alright, coming back down the steps, down the scary steps with no handrail, and back into the clean room. So it might have ended up somewhere in here. Nope. I don't see it. Okay, I'm going to have to find out some other time. Alright, back out of the clean room. Look at this mess. There's stuff on the floor. There's stuff piled all over the bench. Things on top of other things. Embarrassing. Alright. I'll turn this back around. And clip it on there. There we go. And back to here. All right, I'm going to stop at this point because I am both thirsty and hungry, and I really do want to find that other box of parts before. Sorry, I'm just closing things on here. Before proceeding on with more. I think that's the most logical. Okay, thinking about this, debugging this problem.
Aeronaut said, John, you do know there's a washing machine with a coin slot right next to you.
Yes, I do know that. It is, that's a client's machine. So one of the jobs I've been doing is doing the integration of that with a cashless payment system. Right. Yeah, DefPom says you need a handrail. Yes, I do. Okay. What am I... what am I doing? I don't know. I'm trying to catch up on chat.
Creation said, that's awesome.
Right. Yes, we did get to see the PNP running. Sorry, my brain has just totally fallen out. Something has happened. I don't know what I'm doing, but in any case, it is time to end the stream. So I'm going to find the Albot box with the existing USB hub design, which is what this was based on, because there really isn't anything very much to go wrong. If we look at the design of this, provided I haven't screwed up assembly, what we have is a USB connector with the signal coming through to the USB hub, the USB hub has an oscillator. It has some some mode inputs. So if I haven't screwed up those mode inputs, then that should work. All we should have to do is plug this in, and this USB hub should enumerate. It should come up on my computer as a USB device. Even if nothing else in the circuit works, we should at least get a USB device appearing. And there is so little in this circuit that can be screwed up that there must be something fundamentally wrong here. So I want to find out if this is the correct clock. Like, can I send a sine wave clock into this, or does it need to be a square wave? And so yeah, I'll check.
Eastbound's Electronics Repair said the Mac System Info window doesn't auto-update. Sometimes you have to close it and reopen to see changes.
Aha, that's interesting. Thanks, DefPom. So if you couldn't hear that, DefPom said that the info window doesn't auto-update. Sometimes you've got to close it and go back in to see changes. So I was going into System Report and USB and down to here. It's not plugged in at the moment. So the way I'm judging this...
F360 built-in symbols and footprints have USB data lines mixed up.
That's interesting. So that comment was that sorry, Scott said that Fusion 360 built-in symbols and footprints have USB data lines mixed up. Yeah, I'm not using the built-in ones though. This is a USB, this particular connector is one that I have used on many boards.
Override.
Override. Alright, I've just plugged the board back in again. So what I've done is I've just dragged this, you can see here for example.
Aaron Knox says override.
I don't know what override means. The bottom of this is basically in line with where it says Thunderbolt USB 4. Storage, Thunderbolt USB 4. Right, so I'm going to close that entirely, go back into here and System Report, open it again and back to USB and drag this down, and it is still at, oh hang on, I think we have an extra device. What? Really? Seriously? We do. I think this is it. See this thing here? Alright, so just to make sure I'm not going totally insane, please verify. We've got USB 3.1 bus, hub, and then we've got Blackmagic Design, which is the 8M plugged in, composite device, and hub. Now, there are those three. Remember that. Blackmagic Design.
Maker said, did you take a screenshot of before?
No, I did not. So let's do that. Let's take a screenshot of that. And then what I'm going to do is unplug this device. I'm going to I don't know if this is going to do anything, but I'll close that hub, open it again. Nope. Close that bus, open it again. Nope. Alright, I'm going to close System Information, go back into More Info, System Report, and USB. Bring this down. Oh, the device is still there. Hang on, but this is coming down to a different point. Alright, now I'm going to look at my screenshot again. So I'm going to...
said Aaron says, albeit watching the stream through the video and audio quality, it seems like I've had a good drinking session. It's been some great content, John. Great to see the PNP and oven working.
A good drinking session, yeah. This is
Aaron Knox
the
says,
same.
Mitchell R.
USB hub. What's the difference here? Hang on. I'm going to bring that down a little bit so that we can then align this. The weird thing is, it is different, but I can't see where. USB 3 hub, USB 2. It's got the three things on here. 3.1 bus hub, composite.
System notification.
USB 3 hub, ASM
15 minutes ago.
hub. Oh, hang on. No. USB 2 hub. Space Mouse wireless receiver. General purpose hub. Why is that below that? See, this has changed right here. This doesn't actually make a whole lot of sense in terms of the hierarchy. But if we look at USB 3.1 bus, we've got extra stuff in here. There's hub, general purpose USB hub.
The general purpose USB hub.
Yeah, that device there. Okay, I think that might have actually worked. So this is the screenshot, and this is what's currently live. So I'm now going to plug it back in again. Boink, there we go. Close this. Reopen it. System report. USB.
Might have cracked a code. Whoa.
This. Here we go. TI Texas Instruments.
Unexpected maker said, take another screenshot.
Yeah, I could, but I don't think I need to.
Arduino I.
Yeah, check Arduino IDE. So this thing here, this TI device, did not exist when this was not plugged in. So you are absolutely right. Let's check Arduino IDE and see if this device has appeared. Well, we'll see if the I need to. Okay. So I need to. All right. Someone earlier was mentioning about the. Yeah, I was going to end the stream, but I think we're really right on the edge of loading code onto this. I'm going to grab a reset button. Now, with the S3, when it is connected for the very first time, I'm pretty sure it doesn't enumerate. You have to put it into bootloader mode the first time. Is it that button? No. This button. So, that button's got bent pins.
Unexpected maker said needs to be put into download mode.
Yes, exactly. So, I am.
Mr. said we cannot end the stream. Just take a sip of water or something and let's continue. Haha.
Yep. So I've got the snoot button on there.
Said yuppie download mode. I've had to roll this stream with correct suggestions.
You have. So I'm just going to put on. I could have done this with putting a pair of tweezers or something across the reset button as well, but I need to put a reset button on here, so might as well do it properly, because the snoot button is the surface mount one that was already on. Oh, come on. But the reset button was not installed yet. Okay, so we now have the USB hub enumerating. Alright, so we've got a reset button and we've got a boot button. So, what I'm going to do is, I'm just going to plug it back in here, flip back to desktop view, and see what changes. So if we go into the tools menu, port, there is nothing there. Okay, now I'm going to put it into bootloader mode. Hold down the snoot button, press reset, let go. Now, is it going to appear? Port. No.
Said squirrels cross.
It didn't appear. Okay, so I'm just going to try that again. Hold that down, press reset, let go, back into here. No, it hasn't appeared. Okay, so there is something else going on, perhaps. Alright, so the next thing that I would try is, yeah, this stream is going to run way over time. But the next, if I keep going, the next thing I would try is putting a USB socket onto here. Yeah, I really do need a drink of water. I need a little intermission holding screen or something for doing that sort of thing. Right, so the next thing to do is test whether the USB hub is actually working. And
Unexpected Maker says you should see it anyway as a serial PRT. Should be seeing boot loop.
Yeah, but there's no there's no serial port for it to attach to. If I do this, there is no. Oh, hang on, come back to here. The port just isn't there. It's neither of these, so I can't connect to the port. It doesn't exist. All right. So what I'm going to do is I want to determine if the USB hub is working. And the way I'm going to do that, in fact, let's try changing a couple of things. What I'm going to do is plug this in. I was thinking of trying to plug it.
Should show up as a serial device under Device Manager, under the hub.
Yeah, it should. That's true. So it should show up as something, but there is nothing showing up here at all under that hub. I'm going to close that, come back into here, system report, USB,
Stephen W. says, Sanity, check the board. Are the USB pins connected to the hub?
Yes, I've checked that.
Mitchell R. says, override.
Oh, here we go, general purpose USB hub, and there is nothing below it. So I'm going to, okay. The next thing I want to check is whether it is the USB hub or whether it is the S3, something that's going wrong with that. And the way to do that is to install a USB socket on here onto one of the other ports and then plug a device in and see if we get anything appearing below the USB hub. So I need to find USB connectors, the ones that I want to put on. Here we go. No, not that one. I thought it was. USB. Where did they go? I had a whole bag of USB connectors somewhere ready for this project. I thought they were maybe around here somewhere. Maybe not. This may actually be the thing that stops me from continuing right now, because unless they suddenly jump out at me from the bench somewhere, I may not know where they are. So what I'm looking for are the USB sockets that go on, or could they be out there somewhere? Or could they be in my to-file box? Oh, they are! Oh. Alright, the stream continues. I thought it was about to end. That. Okay, so this is the USB socket for the downstream auxiliary ports. Does it fit? I haven't validated this footprint. Oh, it fits. Excellent. Okay, so we'll solder in this connector and then plug a device into this port and see if it appears. And that'll tell us whether the USB hub is working. So if that port works, it could be that there is something wrong with the other port that's going to the S3, or it could be that there's something wrong with the S3 itself. But in any case, I need to validate basic operation of the USB hub. Come on. I don't even know what I'm going to plug in that I could use to have it enumerate. Maybe like another Arduino board or something. Okay, so we've got the socket in there. I'm going to drag this cable across and power that up. Now I need something to plug into this USB port.
I saw connector pins on the PCB labelled RX and TX. What are they connected to?
Oh, these ones. Those are the serial port that goes to the Kayo pick and place machine. So that's not actually in use right now. This port connects to the ESP32, and that's what does the communications through to the machine. Now, I need a device to plug into this, and we'll see if it appears anywhere. What can I plug in? Oh, I know. I'm going to plug in the UT61 multimeter interface.
Unexpected meter says webcam.
Webcam? Oh, right, as a suggestion. No, I don't have one handy, but I do have this UT61E multimeter interface right here. So, oh look, there's a Steve on that board as well. So if I plug this in, at the very least we should get power. Okay, so we're getting power coming through. That's a start, although that's independent of the USB hub. But what we should have now is the ESP8266 that's in this enumerating as a device downstream from this USB hub. So let's see if that happens. So we've got I'm going to close that, reopen here, system report, USB, and where are we? Look at this.
Austin's_creations said should see it in Arduino.
Success. Yeah, so here we've got general purpose USB hub and USB 2.0 serial has appeared below it. That is the UT61E multimeter interface. So if we now, yes, as Austin said, if we now go into here and go to Tools, Port, look at this. That is the interface for the USB serial. That is really cool. So that means that our USB hub is working. And just to validate, I'm going to validate that the other port is working as well. So I'm going to solder a connector onto this port, and then we should be able to connect a device onto that. Now this doesn't actually solve our fundamental problem.
Says, I'm betting the misalignment of the S3 is the issue now.
Scott, yeah, you probably couldn't hear that, but Scott said that he bets the misalignment of the S3 is the issue now. That could very well be the case. I should go along and at the very least rework the connections on that, because there might be, oh come on, get that solder to flow, come on. Just checking whether my head is in the way of the camera. It's not. I'm doing this while sitting back away from it, so I can hardly see what I'm doing. Okay, so second USB port is now fired up.
Unexpected.
Plug that back in again.
Do you have your pull-up and tap on the reset line on the S3? I can't see it on the board.
Oh, that's an excellent question. I will check that. I think that it's a little bit hard to see in this view. But you can, oh, hang on, no, that's the snooze button. Yeah, that resistor there. Oop, if I move it here, that little resistor there, just to the right of the reset button, that should be the pull-up on the reset. But as for the capacitor, that is a good question. So for now, I'm just going to check the second port. So the auxiliary port, we've got power coming through, and coming back to this view. Okay, so we've got port here.
Notification.
11:4:10.
I give up.
Yeah, we're half an hour past now. All right, so the port is there. Okay, now I'm going to unplug it from the board, come back in here, and the port is gone.
Said, and why is there a resistor on boot? That's wrong.
Good point. Let's do a quick review. So it's quite likely that there is a design problem around the S3 module. Okay, so we've got, just to check, just to summarize, we now have a working USB hub. We know that auxiliary port 1 works and auxiliary port 2 works. Auxiliary port 3 is what goes to the S3. So, we're making progress. Alright, so what's going on around here? Now, we've got, this is where I probably screwed it up. Alright, so on IO0, where are we? Alright, IO0, this is what puts it into bootloader mode. There is a 10K pull-up and then the button, the snoot button that pulls it down. Hang on, I can't actually see the chat right now. I've got to quit out of stuff here so I can see the chat, because Sion probably has good suggestions. So Sion says, remove that resistor from the board. That's wrong. Okay, so that is, you're talking about the one on IO0, is that right? And why is there a resistor on boot? Yep. Okay, so remove R17 is the, okay, remove R17, I think is what Sion is saying. IO0 has to be floating. Really? That's interesting. Okay, I will remove R17. Just before I do that, let's just do a quick review in case there's anything else that I screwed up.
Maker says IO0 has to be floating.
Yep, okay. And so enable, which is reset, has a 10K pull-up, and then it's got the button to ground. And what else is going on here that might be a problem? Can't see anything in particular, so I am going to change this to set IO0 to be floating. So where is R17? Where is it on the board? R17, it'll be that one right there. Just below the snoot button. Sion said IO3 changes boot mode for JTAG.
Maker says IO3 changes boot mode for JTAG.
Okay, where is IO3? IO3. Okay, so I've got that currently assigned as, okay, so this could be the problem. I think this is more likely to be the problem, because I've done other S3 boards with a pull-up on IO0 and like this circuit. Just to verify that, I'm going to let me see. I'm just going to switch to what view? That view. While I open something, and if I come to I'm going to go into client projects. I just want to make sure that I have seen this work before, because it could be that my memory is telling me something totally wrong. Alright, I'm going into my modus module. Let's see, this one. I'm just opening something else in Fusion, and then I will come back to a view in a moment where you can see it. Alright, IO0, yep. I'm going to close that and bring this back. Alright, this view, so this circuit is using the S3 module. This is the exact same module that I've got on this board. In fact, it came out of the same strip of tape. And on this IO0 goes to this 10K pull-up and the boot button. And this board absolutely 100% works. Like, I've assembled a heap of these for a customer and it works just fine. So the 10K pull-up on IO0 on the S3 does work. But Sion, I think you are absolutely right. See, in this circuit I've got IO3 strap and it's set as not connected, and for some reason, I don't know why, I'm just going to close that project off. For some reason, I don't know why, on this project I happened to pick that one for I2C. Why the hell did I do that? It's still got the no connect thing on there as well. What a screw up. Alright, so this particular signal it shouldn't go anywhere other than have that pull up on it. So I'm going to remove that pull up. Let's just make sure it doesn't go anywhere. It goes to, oh, come on. Why is that highlighted? That's weird. Very strange.
Unexpected Maker says, but
there
you are also missing the 1UF on N, which will change NN timing.
Yeah, the 1UF on enable. So, yeah, that is true. But I think that this is more likely to be the problem. It'll be putting it into JTAG mode. So that resistor right there that is on IO3, I think if I remove this one, that is going to make it work. And then it probably should have the other cap on it as well. But for now, what I'm going to do is remove that resistor, which is this one right here. So, where did it go? I don't even remember where it went. Oh, that's right. The only reason for that was that it came to the quick connector up here, which was like a last minute add-on. So, okay, that is now removed. Let's come back into here. I'm going to power it up again and come back into, which button am I pressing? This one and this one. Alright, I'm going to open Arduino IDE again and see if we can get this thing to appear. And the screen header. Yeah, did I put a screen header on there? Yes, I did. Okay, yes, you're right. It does go to the screen header as well. That is correct. Now, what was I looking at? That's right.
Unexpected Maker said N can come on before the power rail is fully up in the S3 without the cap, making it fail booting.
Yep. Yes.
Aaron Knox said put in download mode.
Yes. So, port, it's not there, and I will now do the download mode thing. So hold down snoot, press reset, let go of boot, snoot, and is it there? No, it's not there. Okay. Now, this particular thing that I just did should have got around the issue with the capacitor on boot, because if I'm holding down that and then I press the reset button while it's powered up, that capacitor wouldn't be relevant. So I've just done that. It should now be in bootloader mode and it hasn't appeared. Okay, I need to do some more investigation around the S3, but I am now massively over time and I really should call that client back that was calling me during the stream earlier. So I think I am going to stop at this point and maybe do some investigation around the S3 and why it's not. So it may well be that it's just a misalignment of it. I don't know. Right. Okay. Yes, as Scott says, alignment. But if I start messing around with that, I'm going to be here till like 3 in the afternoon. So I'm going to stop now because it's already been way over time. So Sion said, can I solder a cap? Yeah, I can definitely add a cap to the reset line. I can patch one on easily enough. However, and I will do that. However, the test that I just did to put it into bootloader mode, which is you hold down the boot button, which is IO0, so it pulls IO0 low, then press reset, let go of reset, and then let go of the boot button. What that does is assert reset while the chip, I know I know Sion already knows this, but this is just reviewing it from my own, to clarify it in my own head that I am actually testing the right thing. So that will then give it a clean reset signal while power is applied to the chip, which means that the timing doesn't matter.
And make the phone call, and then resume later.
And then resume later. No, I actually need to assemble some boards this afternoon for another client, for CSIRO actually. I'm doing some assembly work for them at the moment. Yeah. Now, yeah, so that is doing the boot that way, using the boot button and manually pressing reset while powered up, avoids the whole timing issue around the enable line because the chip is already powered when it's being manually reset. So the fact that I just did that and the chip still did not appear
Aaron Knox said also get a new broadband
means there is
provider.
something else going on. Yes, I should get a new broadband provider. Yeah, so I need to add that capacitor to ensure that the chip always powers up cleanly on power up. Like it comes up properly. So that holds the reset line low while the 3.3 volt rail is stabilizing, and the ESP32 can then boot properly.
Aaron Knox said the third world appears to have better connectivity than you.
It does. All right. Okay. Yeah, Austin says still needs a cap for the proper signal. You're right, yes. In a powering from like a cold boot situation, yes, that cap will fix the reset line issue. But for the test I just did, it's not required. All right. I'm going to go and deal with stuff. And, yeah, well, we did have some success. We got the USB hub going. That's a start. So hopefully next week we can have the board fully functioning and firmware loaded on it, and maybe even drive the machine from that board next week, which would be really cool. So have an awesome weekend, and thank you very much for coming along today and going on this adventure with me. And I hope you have a good time for the week, and I will see you. See, I don't even know how to end the stream. I do not know how to end the stream. That's why they never end. So I'm just going to say goodbye. Bye.